When we talk about electrical axis in the ECG, we usually mean the mean QRS axis, even though it is possible to calculate the axis of each component of the QRS like initial activation and later activation. We usually mean the mean QRS electrical axis. And electrical axis can be calculated for the P wave, PR segment, QRS complex, ST segment and T wave. All can be calculated separately. Modern ECG machines with inbuilt computerized diagnostic algorithms usually display a clock face in the printout which will indicate the axis of P wave, QRS and T wave. Along with that, the measured axis of each wave will also be displayed in the printout of the measured values. Simple method of calculating the QRS axis is by looking at lead 1 and AVF. The negative waves are subtracted from the amplitude of the positive waves and the resultant taken for lead 1 and AVF. And lead 1 is given an axis of 0 and AVF an axis of plus 90. So this amplitude, the sum of the amplitudes, that is negative is subtracted from the positive, is plotted along the graph. It will be plotted here, lead 1, and AVF will be plotted in this direction. And geometrically you can calculate the resultant. That is what we will get as the mean electrical QRS axis in an ECG. So if both are positive, we can see that the QRS axis will be between lead 1 and AVF, 0 to 90 degrees. That is the normal axis. Simply, this is the normal axis if both are positive. If lead 1 is negative and AVF is positive, then QRS will be in this quadrant, beyond 90 degrees but less than 180 degrees. That will be taken as right axis deviation in this quadrant. If lead 1 is positive and AVF is negative, then it will be in this quadrant. Axis will be in this quadrant and it is taken as simply as left axis deviation. In that there is a division. If it is less than say minus 30 degrees, that is in this region, it is taken as minor left axis deviation, and if it is beyond that, it is taken as true left axis deviation. Sometimes up to minus 30 will also called as leftward axis. A true left axis you need in this quadrant beyond minus 30 to minus 90. Now what happens if both are negative, both AVF and lead 1 are negative? Then the electrical axis comes to this quadrant. That is known as northwest axis or indeterminate electrical axis. Indeterminate electrical axis. It can be an extreme left axis deviation or an extreme right axis deviation. From that highly simplified determination of QRS axis, we move on to a more accurate determination using this Hexaxial reference system, in which each lead has an axis given. This is the positive of lead 1 and this is lead 2, AVF 90 degrees, lead 3 120 degrees. In case of AVR, as all the complexes are inverted, you will have, if AVR is negative, it is plus 30, and if AVR is positive, then it becomes minus 150. So in this hexaxial reference system, we look at which lead is having maximum QRS deflection. Suppose the maximum QRS deflection is seen in AVF. When we look at the lead perpendicular to that, in lead 1, you will have minimum QRS deflection, which may be sometimes equiphasic. In that case, you know that the axis is along 90 degrees. Minimum QRS deflection along lead 1 and maximum along AVF. Then it is plus 90 degrees. And when the QRS is almost equal in two leads, say for example in AVF and lead 2, then the axis will be somewhere in this direction. Maximum deflection is between AVF and lead 2, or rather both are having equally tall QRS complexes. Then if you look at the perpendicular region, in this region you will have minimum QRS deflection. That is in AVL and lead 1, you will have minimum amplitude. That's the second way of finding out the axis. If you are not seeing a lead in which the QRS complexes are equiphasic, then you look at the transition. Suppose say lead 1 is positive and AVL is negative. Then you know that the transition is between AVL and lead 1. We will take it as say minus 15 degrees. Then you look at the perpendicular location. The QRS axis will be here between 60 and 90, that is plus 75. Suppose the transition is between AVL and lead 3. AVL is positive, lead 3 is negative. Then it will be minus 45, that is the transition zone, and QRS axis will be in this region, plus 45. So that's how you look at the QRS axis when there is no particular lead which is showing equiphasic QRS complexes.